Good morning. So we are discussing IoT technology module 3. Myself Pradeep Kumar from Department of CSC, AJ Institute of Engineering and Technology, Mangaluru. In this module 3 of IoT, so we are discussing about IP, Internet Protocol. So how we can incorporate Internet Protocol in our IoT as a smart object in a network layer. So nothing new in this. So whatever we studied in our previous semesters or previous subjects like computer networks, data communications, we are incorporating those things in IoT so that we are making the physical object as a smart objects. So how we can deal with those data, how we can transmit those data in intranetwork or internet by incorporating IP, Internet Protocol. So nothing but we are embedding Internet Protocol with respect to network layer of IoT. So we'll proceed further. So, so coming to the first slide, IP as the IoT network layer. So Internet Protocol as IoT network layer. So as we know, Internet Protocol deals with various algorithms which may help us to pass or to send or receive the data from the internet, or we may send the data to the internet so that we can store those data either in internet, either a centralized server, or maybe in the cloud, or we may pass those data into another machine over the internet. So now coming to Internet of Things or IoT. So the thing is, however, we are making or we are giving life to the physical object so that we are making the physical object as smart objects. So now to go with this particular terminology, the things is nothing but the physical object, we are making it smart. So we are making use of that particular things which should consume or control or monitor the data. On the other hand, each smart object may have n number of sensors. Those sensor will sense the data. So that particular data may be consumed by the data center or by the cloud or by the database, or on the other hand which may be controlled in the sense either we may convert that particular sensed data into another format, or we may take only some part of that particular sensed data into our research or process, or based on that particular data we may give some command to the actuator in such a way that it may control the nature in the sense where we adopted the smart objects, and along with that monitored so that the data can be monitored throughout the day or throughout a particular period of time by the data center servers. So these are the four things we may want to accomplish with respect to IoT. So to accomplish these three major things, that is data consumption, data controlling, data monitoring by the data center servers. So to do with this, we supposed to send the data to the data center. So the data center servers maybe we may kept in the cloud, or we may be kept in a remote location. Either it is a distributed or centralized. For example, so we all have a email ID. We are going to upload the data into our email or Google Cloud, say for example. So we will upload all those documents into Google Cloud so that we can utilize, or on the other hand Google Drive is the best example for the cloud. So we may want to download, we may reuse it, we may update that particular document whenever we need it. Same technique we are going to apply in this sensor data as well. So we can store that sensor data, we can monitor that particular sensor data, we can control that particular sensor data. We'll see an example at the end of this particular discussion with the slide. And then second point is we have dedicated applications for a particular smart object. So using those dedicated applications which can run over virtualized or traditional OSs. So virtualized operating system we are already familiar with. So if you have any clarification, we'll see those things also. Or traditional operating systems or an network edge platforms. Nothing but to deal with this, the previous point, nothing but to deal with the sensor data. So we had 3 points: consumption, controlling and monitoring. So to deal with these 3 points, we supposed to write a dedicated application, or we may make use of dedicated application which will incorporate these things, so that the dedicated application will run on either traditional operating system or virtual operating system. So what we are trying to say is, so we can have dedicated application which may consume the sensor data, or which may control the sensor data, or which may monitor the sensor data through the data center, either it is distributed or centralized. Then we have something called lightweight applications. So lightweight applications communicate with the data center servers frequently. So lightweight in the sense, some part of the dedicated applications which will come into action during the execution of a process, then that particular individual process will look after those data center activities. That's what lightweight applications. We'll see some of the examples with that. Then, so to deal with these things, that is to deal with the sensor data, we may develop a system solutions which combines those layers: physical layer, data link layer. So these different layers we already discussed in architectural, different architectures. We have seen 3 different architectures. Can you recall? Yeah, one is M2M, one machine to machine architecture. Second one we discussed IoT World Forum architecture. Third one we discussed simplified IoT architecture. So in these 3 architectures we have seen physical and data link layers, how it works, what are the importance of those layers. So those 2 layers are common in every way. So by considering those 2 layers which are independent, either to lower level or upper level, it's not dependent. How it is independent? Because its job is to receive the data from the top level, or on the other hand from the sensor is in physical layer, it will identify the data, so it will sense the data, so that particular data is sent to the data center. For example, consider uh, we have a smart object we set up in the classroom. So classroom is of size say classroom is of size around 200 square feet, 200 square feet, a small classroom. So consider I have few sensors set up in that. One of the sensor may be maybe temperature sensor, second one camera module, Wi-Fi module. So these 3 are embedded in a particular smart object, saying that we give life to the class. So now what I do is, from morning 8 o'clock I prepare an application, dedicated application. Its job is to monitor the temperature throughout the day in that particular classroom. So now what happens is, now go back to the first point in this particular slide. The data is consumed, controlled or monitored. So the temperature data should be continuously monitored. If the temperature increases, consider as a situation, if the temperature is increased more than 30 degrees Celsius, then I'll increase the speed of fan. So the increasing the speed of fan is done by the dedicated application. So now increasing is nothing but we are controlling. On the other hand, we may decrease it. So now the sensor data we consumed already, because we gone through with the temperature sensor, and we supposed to monitor because of the temperature increase, that should be monitored, right? So that is as an example. So that is a dedicated application. Similarly, if I have a Wi-Fi module, So these data I can send to the server so that I can have a copy in my server or maybe in the cloud, so that I can compare tomorrow, or I may forecast tomorrow by having those many data. The temperature forecasting, I can do that one also via using dedicated applications. And then Wi-Fi module, we are very much familiar with. You're supposed to upload those data into the cloud. Then the camera module. So based on number of students strength, if there is a very less student strength in that particular class, then no need to increase the speed of the fan, because very less temperature. So the temperature increase is very less. If there is a huge crowd, then automatically the suffocation may occur or some other reason, right? So there is a very less overhead. So this is a small example for this one. I guess you people understood. We'll move on. Next, we have some major advantages of internet protocol. First one, open and standards based. So some of the specific standards is already set by the IP, and then it is open source. So that is a major advantage of incorporating IP in IoT. So that is nothing but common features. We have some common features that we can incorporate in any way, in any method, in a small network, either in private. We know something called LAN, WAN, MAN, local area network, wide area network, metropolitan area network. So based on these three technologies, so we can incorporate IP so that we can easily say it is open and standards based. We have some specific standard that should be followed while connecting to the network. So it is open source. On the other, open source or open, so it will enable us to edit whatever we wanted to see, whatever we wanted to transfer. So based on that, it is more advantageous. So it is a standard, and then it is versatile. So with respect to internet protocol as versatile thing, you can incorporate in any level. It is ubiquitous. So the ubiquitous right now in today's era, for example, last from 2 years, 2018 onwards, the ubiquitous computing is one of the hot topic in the industry, or even in the right now in the market. Ubiquitous computing. So everywhere automation is going on. So it's supposed to every manufacturing industry or logistical sector, home automation. So these are few as an example where everything is automated. So nothing but we are automating via the help of these sensors and actuators. So to deal with that, we have something called ubiquitous computing. So now with this ubiquitous computing, so IP can be easily cope up with this. Then it is scalable, manageable, and highly secure, stable, and resilient, and the innovation factor. So these are the major advantages of IP, Internet Protocol. Then we have something called adoption of Internet Protocol. So adaptation means application layer gateways can be implemented to ensure the translation between non-IP and IP layers. So we'll see in detail about this adaptation. Nothing but whenever we wanted to implement our sensors, so then we need something called ALG, application layered gateway, based on the sensor that we use. So if we need this, we can relate, for example, we can relate with this APIs. We are very much familiar with the APIs, application program interfaces. On the other hand, we may relate with system calls also. In Java, if you compare with the Java, with respect to APIs, we have something called free or wait or sleep. These are all system calls, right? On the other hand, it is API. Using those functionalities, we are giving command to the compiler in such a way that it will obey those rules and regulate those orders, those instructions. Similarly, we can compare that particular thing with this application layered gateways also. So to ensure from non-IP level to IP layers, for example, if you consider same as an example that we discussed in the previous slide, we have a smart objects with the 3 sensors that we set up in a classroom. So from the basic layer, say physical model, physical layer, and on top of that we have MAC. On the other hand, it is data link. So from that particular point onwards, it is a non-IP. So from that non-IP section, we are supposed to upload those data or send those data to network IP layers. So to deal with from the bottom layer to the top level, we need ALG, that is application layered gateways. So to deal with this application layered gateways, we are supposed to adapt, that is what we call adaptation. And we have something called adoption. So adoption is nothing but which involves replacing all non-IP layers with their IP layer counterparts, simplifying the deployment model. Nothing but we can replace something that will give us the functionality of this ALG, either direct conversion or we may write our own program so that it can incorporate those deployment levels, that is adoption. So now to deal with those things, we have some factors. So which these factors will affect, or which these factors is supposed to identify these factors and its applications with respect to our own projects or research with respect to smart objects where we are going to use IoT. So now with respect to that smart object, we have something called last mile connectivity as a terminology. So nothing but from the processing part, processor is supposed to connect to the last mile, that means end point. Say you have a sensor, if you consider previous example, temperature monitoring, the temperature sensor is the last end point to connect from that sensor to the processing level. So these are the factors we supposed to consider. What are those factors? First factor, bidirectional versus unidirectional data flow. Whether that particular temperature data should be bidirectional or unidirectional data flow. In general, if you consider temperature sensor as an example, it is a unidirectional data flow, because whenever we run our application, that is to monitor the temperature in the particular classroom, only thing is we supposed to read the data. So only the data should be sent from the sensor towards the processing layer or towards the viewer or towards the cloud, only one direction. So there is no need of bidirectional. So now why this factor is important is based on the sensor that we use, one thing, what we do with those sensor data, the second thing. So now with respect to the data, whether we wanted to transmit the data in only one direction, that is unidirectional, or bidirectional, to and fro, whether you wanted to convert that data, the temperature data in Celsius to Fahrenheit, Fahrenheit to Celsius or something like that. So then if you want to transmit that particular data into another sensor, if that is the case, then it is a bidirectional. Second point is overhead for last mile communication paths. So what are the overhead? Say if it is a bidirectional, it's always a overhead, right? Whether you're supposed to certify, you in the sense the application should certify whether the data is reached at the end point, the last mile, or on the other hand, which data can be sent to the last point. So there is no acknowledgement in between these things. That's why it is always an overhead for last mile communication paths. We'll see in detail about these things in coming slides. And then data flow model, which model we supposed to incorporate in our project, in our research. So we know different data flow models, right? Based on the data that we wanted to share, unidirectional, bidirectional, and few others data flow models. Then network diversity. So based on the different networks, for example, take the same example of the class monitoring with the using temperature sensor. So from that individual classroom, say for example, consider in one floor we have around 20 rooms. If I incorporate this particular smart object setup in all those 20 rooms, I will make a LAN setup so that I can have all those 20 rooms data in one particular file, or I'll upload into separate document in my server or cloud. Then if a particular building is having 20 is having 4 floors, then 20 into 4, 80. So now if I have more than 2 buildings like that in one campus, then you're supposed to incorporate LAN and WAN as well, right? So now there is a network diversity. Different types of network we supposed to incorporate to set up the project. So to deal with this kind of situation, we may need to make use of different kinds of networks. So that's why these are the factors that we supposed to look after when we are implementing the project, or when we are doing some research on this, and we supposed to select the sensors, the data which can be read irrespective of networks for the last mile connectivity. So these are the major factors that we supposed to consider. Moving further, so why we need with the optimization? So that is, with respect to optimization, there are constraint nodes. So constraint nodes can be classified into various categories again. So with respect to constraint nodes, these are again the devices very constrained with respect to resources. Nothing but we can't control wherever we need or whenever we accomplish. We, or it may communicate infrequently. For example, it may say a few, it will send few bytes of data after 1 minute. After immediately in the second minute, it may send random data, not random data, the larger size data, maybe 10 bytes of data. Again, after 1 minute, it may send 1 KB of data. So infrequent. There is no, for example, there is no filter or something like that. So it is continuous process, infrequent. There is no match in between the size of the data. Sometimes it is lesser data, sudden rise in the size of the data, and it will have very limited security and management capabilities. Security in limited security with respect to that particular terminology. So anybody can access that particular data, and management. So you can't transfer the one data metric into another, and so on. Then the need of optimization is device with enough power and capacity to implement stripped down IP stack or non-IP stack. Enough power capabilities. So we have seen different criteria, whether we are going to make use of battery rechargeable power supply, dynamic power supply, static power supply, continual power supply, and its capacity to handle with the data. So based on that, we may go with the optimization. And some devices may be similar to generic PCs. Some tiny computers like Raspberry Pi or Arduino or Intel Galileo will have similarity with respect to normal PCs, computing, clock speed, but only thing is we have a constraint or restricted to networks capacities. Say for example, we may call it as bandwidth. So, so these are the major need for optimization with respect to IP. So if you compare with the previous setup, that is in the older days, we had very less bandwidth, network band is very less, there is a very limited with respect to technical things. So after that technology advancements happened. We had low speed modems. Once upon a time the BSNL provided with the modem, we had dial-up connection. We supposed to dial the number which is provided by the service provider, say BSNL. So we will hear those beep sounds. After some time, after waiting 2 to 3 minutes, the server is connected. Then using a browser is supposed to open a Google page. After that is supposed to type something that we wanted to search. Again it will take some time because it had very less bandwidth. Once upon a time we used the internet in 10 KB speed, 10 kbps. After the technology advancement happened, so these are the constraint networks characteristics and some of the high speed connections which is not suitable for some of the IoT devices. That is very because the capability to handle those amount of data, if you have high speed connection, it is very tough job to do with the sensor data from the sensors because of because the deployment is itself with the low bandwidth and limited distance, very restricted place. So that's why we call it as constraint network. So these are the things that we supposed to look after when we select with the different devices, endpoints, say sensors.